Hello everyone, welcome to another workshop brought to you by Code Labs Academy. In today's workshop, we are going to talk about deploying your machine learning model using only Python. So let's start. Our objective for today is to learn how to deploy a machine learning model throughout a web application using only Python. We're going to discover the tools to do that. So before that, let's first talk about model deployment. And let's talk about some details here. So after training a machine learning model, sometimes we need to make our model available for different kinds of users. So data scientists might need to share the results with stakeholders of a company, with the customers, if they have such products, with colleagues, and for collaboration and sharing the results. So in these cases, data scientists find themselves obliged or in need to deploy, or let's say share the results and their model. So we may find ourselves in one of these three cases where we are deploying a model. First case is deploying the model as a web service. The second one is deployment for batch prediction. And the third one is embedded models. So we are going to talk in details about each case of these three. We might have other cases of deployment machine learning models, but I think this is the most common ones. So let's start first with deploying as a web service. So deploying a machine learning model as a web service means that users from internet or from a network can access it and interact with your model. And one way of doing it is to deploy the model on your own infrastructure. So for instance, here we have a machine learning model that we can share using a web framework such as Flask, which is a Python web framework. And then you can have like interface, for instance, UWD SGI that will help us to load balance the model and share it using a reverse proxy. For reverse proxy, we can use, for instance, Nginx. So what's happening here is users use HTTP protocol to connect to a reverse proxy, and the reverse proxy will allow us to share a resource, in this case, our machine learning model, to the outside users. And this is an example, one example of a Pythonic stack that will help us to deploy a machine learning model. So a second way to deploy a machine learning model as a web service is to use cloud services. There's many cloud services, for instance, AWS, Lambda, Heroku, some Google Cloud functionalities, and Azure functions, for instance. And there is many other products that help you to deploy a machine learning model, but we are not going to discuss this in this workshop. We are going to focus more on deploying a model using only Python. So deployment for batch prediction, this is the second case, and here we are talking about sending samples of data by batch or chunks of data to our model in order to do prediction or maybe training. So it's not a real-time access to the model, but we send the data that our model will deal with, and we are asking for a scheduling of tasks. So when the data comes, we are scheduling new jobs, and that will be executed at certain points to do the training, to do the prediction, and then the result will be sent back to the client. And Perfect is a Python library that is usually used in these cases for scheduling tasks. And so here we are using the real-time prediction, but it may be useful in other cases. The third case is embedded models. So when talking about deploying machine learning models, we sometimes want to deploy them on Android systems, on some connected objects. And these devices have limited computing capabilities. So we might want to think about, for instance, using TensorFlow Lite to convert and run TensorFlow models on a mobile and embedded devices. So this was the three cases of deploying a machine learning model, the main cases. And today we're going to focus on serving it as a web service. And this can bring us to talk about what we are going to build for today. So today we are going to build a CLA Translate, which is a web application for machine translation. We're gonna also discover Anvil, which is a framework used for deploying web applications using only Python. So exactly what we are going to do is building a translation application by building a small, simple web UI, and then building a machine translation model and deploying CLA Translate, and all of this using only Python and also Anvil, which is a Python library and other solution component also. So let's start coding here. Okay, so let's start first talking about machine translation models. So in this case, we are going to use Hugging Face. Hugging Face is an AI community or AI initiative that open source a lot of machine translation models, and not only machine translation models, but always also other machine learning tasks. For instance, we have a text-to-speech task, we have image segmentation, and much more. So as you can find here, by under the Helsinki NLP initiative, we can find many languages or language models, machine translation, and we are going to use this in our case. So in order to be able to use these models, as we just discussed, we need to use transformers, which is Python library, to implement and train transformer architecture, which is deep learning architecture that is based on attention mechanisms. So this is not our topic today, but we can talk about that maybe some other times. So let's start here. So we have translation case. So we need a source language. For instance, let's choose German, DE for German, Deutsch, and then let's choose the target language, which can be English, for instance. And okay, and we also need a text to translate. So we have a kind of, I don't know. Okay, this is our German text, and now we need to let me zoom in a bit. Okay, and now we are going to call our model. So we are going to use transformers and import Marianne tokenizer and Marianne machine translation model. So our model will be Marianne model and dot from pre-trained. So we are getting the pre-trained version. This is a model translation model trained prior on machine on a big corpus or data set of the English Deutsch data set. So, and here we're gonna put the model name. Okay, and we also need to get a tokenizer. We need a tokenizer for this task also. So we are going to use get the tokenizer also from pre-trained and model name. Okay, so what is the model name here? So there is a convention about the model name, and let me show you here what it looks like. I have prepared this just to get it fast. All right. So here is how model name could be. We have the source language and the target language. Okay. But this, what we'll do, this a couple of lines will download the model from Hugging Face Hub, and it's about 300 megabytes. So I already downloaded it and stored it to my local machine here. And here is the couple of lines that you need for storing it. So let's just instead use this one from my local machine and not download it again. Okay. Okay. So we need also a couple of lines. I got here. These couple of lines will this is model.generate that will use the tokenizer that we have here, and we give it a text, and it will give us the translation in here in words. So let's give it a try, and we should have our results in here. Okay, this is a deprecation warning. And then let's see. Here we go. We have our translated sentence in here. I have no idea. Okay, cool. So we have our machine translation model. So let's now focus on the deployment part. For deploying, we will need to install Anvil and Blink using this command. So let's take a look on Anvil. What's Anvil? Okay, so here Anvil is a tool that will allow us to deploy machine learning models, and not only machine learning models, but deploy code in Python, and it is based on Python. So we can find here many cases of how to deploy. You can deploy it on your own hardware, machine, solution, etc. So let's practice. Let's learn by doing better. Okay, so let's access Anvil here and let's start building. And here we have like create an application. Let's create a new application and let's choose here material design. Okay, here you can see a drag and drop editor that we can use to build the small UI. So let's build quickly our UI. So we need a drop down to choose the language. Okay. This is for the source language, and another drop down to choose the destination language. Okay, and we need a button to start the translation here, and also we will need a text zone to enter the source text in the source language. Add some spacing here, and we will need also a text zone to display the translated text. Okay, that's about what we need. Let's start here. So for the drop down, let's give it a name. You will see why this is important later. This is for calling it this item from our backend, our code that will be in Python. So this is the source language, and this will be the target language. And the button here, let's give it a name, translate. Okay, let's give it some style. Okay, where is it? Okay, some primary. All right, translate. Let's give it text here, translate. All right, and here also, let's give it a name. Let's call it source text. And here, let's call it translated text. Translated text. Okay. All right, so let's focus on this button because all the magic will happen here. So when we hit this button, we need to start the translation. So we need to build an on-click event or on-click action for this button. So let's call this translation, and let's hit this button in here. Okay. So this will take us to this auto-generated Python code that we will work on. So the translation is the on-click function that we will use in here when the button translate is clicked. So we need to get information from our UI and send them back to the server and send them back to our Jupyter notebook. So let's get the data. So we need the source language, and source language is in self dot source language dot selected value. And let's also get our target language, which is in self dot target language and selected values. Okay, and also let's get the text. So the text is source is where, let's call it source text also. And the source text is in self dot source a source text. Where is the source text? I did name it source text. We have check again, maybe. Okay, and let's fix this source text. All right, let's get back here. Source text. Okay, dot text. Okay, now we need to send this data to our backend. And to do that, we are going to need this line server anvil dot server dot call, and we're gonna give it some parameters. The first parameters is translation, and then we are going to give it this parameters: source language, target language, and we're gonna give it also source text. So what is this translation parameter? This is the name of a function called server function that we didn't define yet. We are going to do that in our Jupyter notebook. And this line will call this server function and give it these parameters in here. And this will return for us the translated text. So, and we just need one more step to put the translated text in our UI. So we are going to use self dot translated text dot content will receive the translated here. Okay, you have the source language, you have target language, you have the source text, and source translated and content translated. Okay, so this is all what we need here from this UI. Let's get back to our here Jupyter notebook, our backend code. And here, as you can see, we will build our translation function. So let's first import this and the translation, which is Python, just ordinary Python. So we just need to respect the order of the parameters that we will receive. We have source, we have target, and we have text. Okay, let's now start building. So we have already there the codes that we can just copy from here, back here. Okay. So loading the model, doing the prediction, and then returning the result. And then words 0. Okay. So we need some more details that I have here. I will explain what is this. So this is for converting a Python dictionary for converting the source and target language to the respective code, the language code in here, since we are using language code to get the name of the model and the name of the tokenizer using these two lines in here. So we don't need this one here. We just need to use the computed now. Why I'm using this format? Because I chose to store the models in my local machines in this path. Okay. All right. Okay, so this will load the models and then do the translation and return the results. So typically we wouldn't load the model inside the function, the server functions. It will be called every time, but this is just for the case of the workshop. So this is the function. We need one more step. The step is how are we going to tell Anvil that this is the function, this is the server function that you should call or you should search for. So we need to use Python decorator to tag this function as anvil.server.call label. So this will make this function a server function. So let's run this cell. And we need one more step. So we need anvil.server.connect. And we need some string here. So this is, we'll start an Anvil server. on our local machine and connect to our UI for sending and receiving data. And the string here that will make the connection happen, we will get it from here, from the UI of Anvil. Okay, so we go here to parameters and hit the gear and then uplink, and then here enable server here, and we're gonna get this code right here. So again, the gear and then uplink. Okay, and let's get back here and paste our code, and let's run this up. And we can see here that we have a connecting server to Anvil.works. And let's go back to our online editor here. And let's run this application. So let's give it a name. And here we see our application running. So you can see here that we have nothing in here because we didn't specify anything, but this is how the application should look. So let's get back, stop this, and go to the design. And here, let's put some items. So let's choose the languages. For instance, German, English, Spanish, why not? And here for the destination language, let's choose English, maybe French, etc. Choose whatever you want. So let's add something here also. Let's give it the title. Would be nice. All right, so put the text here. See how they translate. All right, so let's run again. Now I'm gonna wait a few seconds so it will start. Again, waiting for this. Let's get back here and see what we have done. We have like built a machine translation model, downloaded from Hugging Face, and we can use it in our case. Remember that these models can be trained on your local, on your own data set, making them better performance, give them better performance. And then this model will be used using a function called server function, and we tagged it from Anvil server function. And so here we are going to load the model, do the translation, and then send back the result. And this connection is enabled using this code or line of code. So let's get back here and see. Okay. I'm waiting here for it. It's taking some time. Okay, let's run it again. All right, okay, it's good. So here we can choose options of the language, source language, and the destination language from here. And let's put our line in German here. And let's hit translate. Okay, so we can see here that we got an error, and we can, from this screen, debug the error, which is very helpful when developing. So we see here that destination is not defined. So let's get back here. Why I knew it's here, because you can see here, this is IP kernel, so IP kernel, so this is from my notebook, and the error is in this. So this is not defined, so we should instead use target. So let's use target. All right, let's run this again, and let's get back here. Okay, so let's try the translation again. And you can see that we have our translated received in here. So we have built a application that we can publish. So in this here, top right corner, you can see publish this app, and it will give you a link that you can copy and access this application from a web browser, as long as your Jupyter notebook is on and your machine is connected. And so we were able to build really quickly using only Python, and Anvil, of course, a web application that do translation. So you can see that this is very easy to do and very intuitive. So let's get back here to our presentation and talk about a couple of two things here. So if you want to get here, so guys, we have built a machine translation model using Python and this workshop, and we have more workshops for you of this kind if this is interesting for you from Code Labs Academy. And Code Labs Academy is a highly live interactive learning platform, online platform that will allow you to have access to one-to-one career coaching and a number of TA teaching assistant that will guide you and be with you all along your learning journey. So this is not only a online course, but you will have a human interaction and people will help you push your limits and get the best out of the courses. And there is multiple topics such as data science, web development, cybersecurity, and others. So yeah, if you have any questions, feel free to take a look on our websites. We will put an article about this workshop, and also feel free to send an email and get in touch. So thank you guys. I hope you enjoyed this session on this workshop, and we'll see you in the next workshop.